So to get you going, let's look at a few basic probability questions, right? And so we're going to be focusing on what we call a regular die. Now, as you know, die is the singular for what we know as dice, okay? Die is singular for what we know as a dice. And as you know, a die or a dice that you roll has got, a regular one has got 6 faces because it's actually a cube, and on each face is a certain number of dots ranging from 1 is to 6, right? So over here we say there's 6 possible outcomes. There are 6 possible outcomes. There's 6 things that could happen when you roll a die. You can either get a 1, or you could get a 2, or you could get a 3, or 4, or 5, or 6. So the sample space over here, I'm going to make a note. The sample space, which we denote by S, is equal to the set containing 1, 2, 3, 4, 5, and 6. Right. So the number of events in the sample space is, of course, 6 events. So everything we do is we would have to look at the number of times that this possible thing could happen out of the sample space, and that would be the assigned probability. So what is P of 1? We read this as P of 1, or the probability of getting a 1, right? If we have to roll a regular die. So I'm going to just put that over here. The probability of getting a 1 is equal to 1 because there's only one little dot that indicates 1 on a die out of 6 possible occurrences. So it's a 1 in 6 chance of occurring. So you can also work that out on a calculator or in your head, and you can get the percentage or the decimal thereof, and that should be 0.167% chance, or 16.67% chance of occurring, or a probability of 0.1, let's say 0.17 rounded. Okay, what is the probability of getting a 7 on a regular die? Now, if you've played Monopoly or any game that really uses these dies, you'll know that there is no 7 on a regular die. And if you have to throw it around and you roll the die, my bad, you'll know that you're never going to get a 7. And so therefore we assign a probability of 0 because it's an impossible event. Okay? What is the probability of getting a 3 or getting a 4? Now there's 2 important things I must tell you before we continue over here. When we talk about OR statements, right, it means that this could be true and that could be false, but the whole statement is true. This could be false and that could be true, but the whole statement is still true. Okay, so when I speak about OR, it means that either one of the 2 conditions must be fulfilled in order to reach that likely outcome, right? So if I have to use an example and I say, okay, you know what? I'll make a deal with the kids in my class to say, if you come early to class, I will give you 10% extra on your maths examination mark, right? Or if you buy me lunch, you'll get 10% extra on the examination mark. So I've given you an or condition. It says either you buy me lunch or you come early to class and I'll give you 10% on your exam. So what does that mean? That means you can either buy me lunch and you get the 10%, or you could come early to class and you get the 10%. So you have to fulfill one of the conditions. Now, you cannot possibly for this type of condition here, 3 or 4, you cannot possibly complete both, right? So when we have to look at the probability of getting a 3 or getting a 4, you have a 1 in 6 chance. So we say probability of 3 union 4. This union symbol over here, it's a shorthand for saying or, right? So the probability of getting a 3 or getting a 4 is calculated as, there's a 1 in 6 chance of getting a 3, and there's a 1 in 6 chance of getting a 4. So the probability of getting a 3 or a 4 is essentially 2 out of 6, right? Or 1 out of 3, that's 1/3. That gives you 0.33 or a 33% chance. So I mean, because I've given you this OR condition, the stakes are lower and you are more likely to achieve this. Okay, now we've looked at events that are likely to happen, events that are impossibilities, events where we have an OR condition and I meet one of the 2, And in this case, now let's look at the probability of not getting a 2. The probability that you draw something that's not a 2, right? Well, in our sample space, you can clearly see that's a 1. This is clearly a 2, right? And all these other things over here, the 1, the 3, the 4, the 5, and the 6, all of these are considered not 2. You get what I'm saying? So when we look at what's the probability of getting a number other than 2, anything else except 2? Well, there are 1, 2, 3, 4, 5 observations in a regular die. Probability of not a 2, which is represented by 2 with a line above, or 2 with an apostrophe or prime. This is known as P of 2 complement. In other words, the complement is not a 2. And how many not 2's do you find there? Well, you get 5 out of 6. Okay. And then finally, I know I'm doing all the answers in red. What's the probability of drawing an even number? Well, you know there's 2, there's 4, and there's 6, right? 1, 2, 3. 2, 4, 6. So it's going to be 3 out of 6, which is essentially 1 out of 2, which, as you know, is also 0.5. And this equates to obviously 50%, and therefore the probability of getting an even number is 50%, which means it's equally likely to also not get an even number. Okay, so there's your basic introduction to probability with a few basic probability questions.